So you want to make a game by yourself? Well, here's all the tools you'll need and how much they cost. I'm David Nadeski, a solo indie game developer on a budget using the Unreal Engine 4. I'm making a real-time strategy/tactics game called HŌRU, where you don't build bases, you build battlefields. So let's get started. What are the tools you'll need? I've divided them into different categories like modeling and animation, texturing, image editing, video and sound, and miscellaneous. And at the end, you see a big Unreal logo because that's where all the assets generated by these tools go into. So the first application I wanted to talk about is called 3D Coat. I use 3D Coat for three things. First one is high polygon voxel-based sculpting. Second one is high poly to low poly retopology. And the third one is UV editing. One of the prime advantages of 3D Coat, besides doing all the aforementioned three things, is that it's cheaper than ZBrush. So much cheaper, in fact, that you can get a hold of the amateur edition for about 90 euros or $100. And I think that's a great price. I mean, if you're starting out and your game is pretty much at a non-existent state, you want to get by as cheap as possible and you don't want to overcommit yourself. And with 3D Coat, you can do that. My advice is that you get the amateur edition first and then upgrade later as you see fit. Now there are some limitations to 3D Coat's amateur edition in that it doesn't support textures above 2K, but if you're using the Substance Suite like I am, that's not really a limitation at all. Also, the license is a non-commercial license, so once your game starts rolling, you might want to purchase the commercial upgrade. There are some limitations in the software. For instance, it doesn't have as many brushes as ZBrush would, but seriously, I haven't found that to be an issue just yet. And I've been developing my game for about 1.5 years now. So 3D Coat is pretty much the industry standard when it comes to retopology, that is converting your high poly meshes into low poly ones. It's also great for doing your UVs, although with the latest update to Maya LT, the 2018 edition, Maya has pretty much caught up to 3D Coat's capabilities. Alright, so next up is Maya LT. Maya LT is the light version of the full-blown Maya, and it costs about 1/10 of what Maya does, and does pretty much everything Maya does but render. So basically it does rigging, skinning, animation, modeling, even sculpting if you want. It has the Human IK plugin or module. It is great for creating LODs, level of detail. It's excellent for hard surface modeling, like buildings and, I don't know, water buckets, whatever you want to throw at it, really. It's got splines, NURBS curves. It has a very good decimation tool that allows you to pretty much take a kit bash and convert it from a high poly, multi-million polygon model into a low poly, few thousand polygons model. So basically what I do is if I have something that I've started working on in 3D Coat, I'll use 3D Coat's UV editor. Whereas if I have something else that I've started working on in Maya LT, I'll just stick to Maya LT's UV editor. So pretty much the only downside of choosing Maya LT is it's only available in a subscription model. So that means you'll end up shelling out about 30 euros or $30 every month to use the software. All right, so next one is Blender. Now Blender can do everything that Maya LT can, and it's completely free. However, I've found some limitations when it comes to rigging, especially with their standard Rigify/Pitchipoi rigs. So in the end, I opted to go with Maya LT. And also Maya LT works a little bit better for me, but your mileage may vary. I still use Blender a little, however. I mainly use it for rendering. So like I said, Maya LT does not support rendering in any way, shape, or form. However, you can export your Maya LT models as FBX files into Blender and render from there. And also, you can connect Blender with something called RenderMan, which I believe the basic edition is free for non-commercial purposes. So if you want to make some high-quality renders, just go with Blender and hook it up to RenderMan and you're all set. In terms of rigs between Maya LT and Blender, Blender is not really that friendly with that, so you might want to bake out your animations and just export those into Blender. And that way you'll have whatever you had in Maya LT without Blender messing stuff up. So next up we have Houdini. Houdini does a number of things very, very well, and one of those is procedural modeling. So you can use this for laying out stuff like fences, walls, basically anything that you could with the spline-based tools in Unreal Engine, but you can achieve a much greater level of detail in Houdini. You can also use it to build complete cities or buildings in Houdini and have sort of a modular configuration once imported into the engine. Like on a second screenshot here, you can see a full-blown city being generated in Houdini procedurally. So Houdini comes with Unreal Engine 4 integration. Unfortunately, it's not in the free apprentice version, so you'd have to shell out a couple $100 to get that. But hey, I suggest you get the apprentice edition first, practice. I believe you get like a 30-day trial of the version that does integrate with Unreal Engine 4. So you can play around, see what it does for you, and upgrade if you want. You can also use Houdini for modeling, let's say, very high detailed objects like rocks and cliff faces that would be very time consuming to do in a traditional modeling application like Maya, or even sculpting with 3D Coder, ZBrush. Houdini's got somewhat of a steep learning curve. There's a lot of systems at play like fire effects, the modeling itself, and everything is basically a node. Pretty much like Unreal's material editor, it's a node-based workflow. So you'll have to get used to that. Next on our list is MeshLab. So MeshLab is a small tool that I use mainly for mesh cleanup, like polygons, normals, fixing alignments, pivot points, that kind of stuff. However, it also has another tool called Quadric Edge Collapse Decimation that will help you immensely when you're trying to get some kit bashes, high polygon, detailed models, and convert them to low polygon assets that you can use in your game. Basically, you just feed it a model, an OBJ file, push a button, and boom. It'll reduce millions of polygons into a couple of thousand if you want. And the results are very convincing. And that'll save you a ton of time because you don't have to go into Maya or 3D Code and retopologize there, spending hours upon hours of getting a simple, let's say, gun mesh to work the way you want it to. So next we have World Machine. World Machine is kind of a niche market. It's used for landscape generation. It's great for open world games and also pretty much any kind of game that needs detailed landscapes. So with World Machine, you don't have to go in and model every nook and cranny by hand. You can just have a procedurally generated landscape and cherry pick regions out of it that you want. Now, I should also mention that Houdini supports dynamic landscape generation as well. So if World Machine is not really your cup of tea, you can also go and do that in Houdini. And this is also available in the free Apprentice edition in Houdini. So World Machine's got a node-based editor, again like the material graph in Unreal Engine 4, and it's got some awesome plugins like Geoglyph 2 that are pretty much a software of their own. And they allow you to do even more advanced landscape generation, but it comes at an additional cost. My suggestion is you get the Indie edition, which will run you about 100 euros or US dollars, and upgrade to the professional edition later if you want things like tile generation and scripting. All right, so next up is SpeedTree. SpeedTree, like the name implies, is used for generating trees, plants, and all sorts of different foliage you want to have in your game. SpeedTree is pretty much the industry standard when it comes to the generation of trees and other types of foliage. And there's a lot of Hollywood movies that use it as well. And also games like The Witcher 3 had their foliage done in SpeedTree. It's also worth mentioning that you get access to a bunch of free assets every month when you have a subscription. So basically there are two aspects to SpeedTree, one being the editor itself, which is fully compatible with Unreal Engine 4. And the other thing are the actual assets, the trees that you can purchase. Now, the trees and plants you can purchase from the SpeedTree store are kind of expensive, at least in my opinion. They'll run you anywhere between a couple of dollars all the way up to like 50 bucks for, I don't know, like a palm tree. And that's probably something that you won't be able to afford if you're watching this video because you want to roll on a budget. But the editor itself is great because you can recreate everything they have on the store with varying levels of detail. And the more you use it, the more familiar you become with it, and the better trees you'll be able to make. All right, next up is Substance Suite. Substance Suite is composed of two main applications, Substance Painter and Substance Designer. There's also some other software in the Indie subscription, namely B2M. Now, let me go over each. Substance Painter. Substance Painter is used for texturing your 3D models. Think of it like the Photoshop of texturing. It has layers, it has PBR materials, and it also has a non-destructive workflow. I absolutely couldn't live without Painter. So if nothing else, get Painter. Seriously, it's one of the best applications out there. And it's very cheap, in my opinion, for what it does. Next one is Substance Designer. Now you use Substance Designer to create materials. Things like metal plates or rocks or something procedural like sci-fi paneling, all sorts of things. You then use these PBR materials and put them onto a mesh via Substance Painter. So you make the textures in Substance Designer and then you use them in Substance Painter. Now the beauty of it is that these textures, or materials as they're called, have various parameters that you can adjust. For instance, suppose you make some rocky sand. You can actually put a parameter in that will control the amount of rocks in your sand. So you set this up in Substance Designer, and once you've imported it into Painter, you just adjust some sliders to get the amount of rock detail that you want. And all of this integrates with Unreal Engine seamlessly. So you import your substances you've created in Designer, and let's say it's something for a landscape, so landscape material. You then import your substance file into Unreal Engine 4, hook up things like base color, normals, ambient occlusion, etc. And then you can adjust your parameters in Engine as you go about editing your material. So there's pretty much real-time feedback on what the final result will look like from something that you've created beforehand in Designer. And I think that's pretty cool. Painter and Designer both support texture baking as well. So texture baking is the process of taking your high poly model, like your sculpt, and your low poly model that you've created either in 3D Coat or Maya or some other means. And then baking will make sure that the detail that's visible in your high poly model will make it to your low poly one. And it does that by creating a bunch of maps, mainly a normal map, ambient occlusion, cavity maps that will link sort of like the differences between the high poly model and the low poly model. It's just magic, so give it a shot. So Designer works in a similar fashion, again, to the Unreal Engine 4 material editor in that it's node-based and also non-destructive. So this node-based kind of methodology is, I think, kind of becoming the industry standard, or has become the industry standard over the past couple of years. Another huge benefit of going with the Substance Suite as a subscription, so the Indie subscription, is that you get access to 30 materials a month from Substance Source. These are very high quality, pre-made materials you can use for free. So basically you get 30 points a month, and these points will roll over the next month if you haven't spent them. So if you've been waiting out for, let's say, 6 months, you'll get 6 times 30, so 180 points. That is 180 high-quality materials that you can download. And you can even keep these materials if you decide to abandon your subscription. Now, the reason you might want to do that, cancel your subscription, is because after a period of 12 months of continuous subscription, you can purchase the entire Substance Suite for, I believe, about 50 euros or dollars if you so choose. So you'll get Substance Painter, Substance Designer, and B2M, another tool that you can use for generating textures from photos like base color, normal map, ambient occlusion, etc. You get all of these for 12 months of subscriptions plus $50 or euros. And then you get to keep all your textures and everything else you obtain from Substance Source. So I think that in summary, Substance Suite is probably the best value for money that you'll find on this list. I think they have like a 30-day free trial as well. All right, next category is video and sound. I've grouped these two together because I'm not really using, that many tools. Basically for video, I'm using OBS Studio, completely free. It will record your screen, so you can record some gameplay footage, tutorials like this one, whatever you want really. Or you can go and stream yourself live on YouTube, Twitch, or any of the other major video platforms. The other video tool that I use is called DaVinci Resolve. DaVinci Resolve is a professional-grade video editor that is completely free, and it's one of the industry leaders when it comes to color grading or color correction. I use DaVinci Resolve with all my videos, and I've edited this video with Resolve as well. So finally, I have one small application that I pretty much use exclusively when it comes to sounds and music, and it's called Reaper. Reaper will cost you about $60 or euros for the limited commercial license. And basically, it's a one-stop shop for all your audio needs. It supports VST plugins, so that is effects and all sorts of modifiers. And it also has a very handy library feature with which you can organize all your audio files in these things called databases. These are just big catalogs of data. You can annotate them, you can put in custom descriptions, it'll read the industry standard descriptions off of these files. So it's a pretty handy tool, and it's seriously the only tool I use for music and sound. Okay, so the next one on the list is called Intel GPA. Intel GPA is a graphics profiler / debugger, and it analyzes frames captured from your game. So basically you launch their monitor application, and which will in turn launch your game, and then once inside your game you'll press a keyboard shortcut and it'll capture the actual frame from the game. And then you can go and analyze that in Intel GPA. It's very detailed, actually a lot more detailed than what comes shipped with Unreal Engine 4. And you can even go down to the mesh level and analyze which mesh has the most impact on performance. It'll also do that for shadows, lights, and will even give you an HLSL code view. And since it is completely free and supported by Intel, I think it's an awesome tool that no developer should live without. An alternative to Intel GPA is called RenderDoc, which is also free. It's not made by Intel, made by some other people. I'll not go into RenderDoc in detail because I haven't used it that much. So basically, Intel GPA does more than I need. Okay, so that's pretty much all the software I had on my list. I also wanted to talk a little bit about project management because I think it forms a very important aspect of game development and it tends to get overlooked. So basically what I mean by project management is the planning and organization of tasks and resources like people. If you're a solo indie game developer like myself, it's very easy, just have one person, but that person needs to get the job done. And where does he get his tasks from? From the project management software. So I use something called Hack and Plan, which is completely free for up to a couple of people. And I basically use it for keeping track of my tasks. So I'll create everything in Hack and Plan first before I touch code or start modeling something in say Maya or 3D code. And I'll always put in an estimate. Now, one of the things about estimates is that they're very difficult to get right, but with some practice and using a tool like Hack and Plan conscientiously, you'll get to the habit of at least making these estimates. So you'll have an idea of how much time tasks in your project are going to cost. And that's great because let's say you want to prepare your game for Kickstarter you'll obviously have a checklist, and all those checklist items are going to be transformed into tasks using your project management tool. And that's very handy because you'll be able to tell how much time it'll take for you to prepare for your Kickstarter or launch date or what have you. And it's also great for collaboration because you can just distribute tasks among team members and check up on status and such. So my recommendation, always use project management software. All right, so now the fun part, costs. How much is all this going to cost you? If you look at this table, I've included 3 summaries. One is your one-time or initial costs. The second one is your monthly costs. And the third one is the total cost of everything in the first year. Now, you might look at those numbers and think that they're too high. You might look at these numbers and think they're too low. In my experience, being a solo indie game developer in 2018, these prices are very, very good. Basically, for $100 or euros a month, you get to develop your game. There's not really much else to it. I mean, you have your modeling applications, your animation pipeline all covered, you have texturing taken care of, video, sound, everything. I think it's a pretty reasonable price. You'll also notice that I've included a couple of entries that I haven't specifically mentioned previously, such as Office 365, G Suite, Photoshop and Lightroom, and a Linux US server. So everything besides Photoshop, I'm going to talk about in one of the next slides. Photoshop is basically just standard. I mean, I couldn't imagine doing without Photoshop. And since Adobe's put out their photography plan, it's really become dirt cheap. So basically about $10, 12 euros a month will get you Photoshop and Lightroom. I actually don't use Photoshop that much, but whenever I do, I'm not really sure if there's another application that could get the job done as quickly as I can in Photoshop. Lightroom is just really an added bonus. I've tried using it for organizing my textures. So far, it hasn't really worked out that well for me. But hey, you might find another use for Lightroom that I'm not aware of. And do tell me about that in the comment section. All right, so how does this all add up? Here is my character pipeline, and I have similar pipelines for working with non-characters like props, buildings, weapons, things like that. So first off, sculpting. I will initially sculpt my character in 3D Coat. It's got the voxel-based sculpting engine that I like very much. And then, once that is done, I'll take the model, the high-poly sculpted model with like millions of polygons or however many voxels. I'll take that into 3D Coat's retopo room. 3D Coat is divided into like these rooms, but anyways, I'll just do retopology. The 3D Coat, that's quite easy. You basically just push a button and boom, you're in retopo mode. Now, 3D Coat has automatic retopology and it works great for organic models like characters, like this giant that you see here. So basically, I'll just unleash 3D Coat's automatic retopology and then fix any errors by hand. Next up, I'll do the UVs. Now, UVs are, again, very simple to do in 3D Coat, and provided you have a good quality low poly model already resulting from your retopology, it's going to be a cinch to create the UVs for that. So once the UVs are done, I'll export the model in FBX to my LT, where I'll take care of the LODs. I like to have them done early on, or at least do the first pass early on so I can see what it does once I animate and texture my base reference. So that is LOD 0. So after the LODs have been generated, I'll take my character to rigging. Now, rigging, if you're doing a humanoid model, is very, very simple in Maya LT. All you do is you just create a human IK, rig, or skeleton and conform the bones to your character's mesh. Once that's done, you'll want to skin the model, a process called skinning, which is sort of like an association of your mesh's vertices to your rig's bones. So here you'll say that, for instance, the shoulder bone is going to affect this region right here around the shoulder of your character. And you do that for pretty much every single bone. in your rig, and once you're done, you can start animating. So animation is, I think, something that Maya excels at. I really have not come across a better tool for doing animation than Maya. It's basically got everything. I'm not going to go into too much detail because that would probably be the subject of countless other videos. So basically the only limitation, as far as I'm aware, in Maya LT compared to regular Maya when it comes to animating is that you only have access to a single timeline. Now that can get a bit annoying, but it's something that you'll eventually get used to. Basically, this just means that you'll have to leave a small gap between, let's say, an attack animation and your regular locomotion, and, you know, just to mark where something ends and the other one begins. But Maya LT's game exporter supports that because you actually specify the start and end frames of all your animations there. And then it will create, you know, as many files as the number of animations you have. The next one is texturing. I sometimes mix this up. So I sometimes texture the model first in Substance Suite and go back and forth, you know, between animating and texturing. This is so that I can track down any extra polygons or edge loops that need to get added. For instance, around the shoulders or the ankles, you might want to have extra edge loops so that your model looks better when animated. Once I'm done with texturing and animation, I'll take the model into UE4. I'll just use regular FBX files. I'll use one FBX for the base model without any animation on it. And I'll use separate FBX files for all the animations that I've done. And the way you link them up in Unreal Engine 4 is via the Unreal generated skeleton. That skeleton gets generated from your Maya skeleton. So yeah, I'll check if the model has imported correctly. I'll import its textures, create materials for them. Normally for characters, I tend to keep it very simple. I'm not using layers or anything fancy because, well, I don't have as many characters as like Fortnite. Yeah, so for me it's just importing the textures and the corresponding and creating the corresponding materials. And once that is done, the final step is when I go into the Unreal Physics Asset tool, or FAT, and tweak the character's physics asset so that it does ragdoll animations properly. So that's pretty much it. That's my character pipeline. So I hope you've found it useful. All right, so you've heard me mention OneDrive and G Suite and Linux Server on one of the previous slides. And the reason why I did that is, if you're going the indie developer route, you'll be pretty much in charge of setting up your own source control. Source control, for those of you that don't know, is something that keeps track of your files. Basically any file, assets, source code, 3D data, textures, etc. Typically, you'd want to have everything checked into source control. And one of the reasons for that is collaboration. So if you have like multiple team members, you can cooperate on the same project and check everything out from a central repository or repositories. So the other feature of source control is change tracking. So you can actually go back in time and see what changes you've made to a particular file ever since you've started versioning your project. When it comes to games, there are two main source control systems. One is called Git, which might be familiar to a lot of you because outside of games, it's pretty much the standard source control system nowadays. And the other one is Perforce. And Perforce is used by most of the major AAA studios out there. I've highlighted a couple of high-level differences between Git and Perforce, but I urge everyone to go to the Perforce website, check out what it's all about, read some articles on, comparisons between Perforce and Git, and just pick the one that suits you best. So basically, Perforce is free for up to 5 users, and it's the industry standard when it comes to games. Git, on the other hand, is free for an unlimited number of users, so there's no cost attached. It's completely open source, and it was actually created by the creator of Linux, Linus Torvalds, and it's seen a very widespread adoption in the software industry in general. Now, historically, why games haven't been using Git so much was because of large assets. For instance, a substance file can very well run into the gigabytes. And traditionally, Git hasn't coped well with larger files, but ever since they've rolled out Git LFS, or large file system, they've pretty much eliminated that problem. So how do you use Git? So first of all, you'll have to set up a regular repository for your regular files, like source code and basically anything that's text-based. And then, alongside that, you'll have your LFS container, which will host your UAsset files, substance files, models, anything that's binary. And this way, you'll get around the limitation of basic Git and have source control at your disposal that is completely free. Now, there's one more thing when it comes to setting up source control, and that is, should you host it locally or remotely? Hosting source control locally is fast, safe, and free. Hosting it remotely, however, enables others to collaborate with you. Also keep in mind that source control generally uses up a lot of space. So if you have a server where space is limited, which in most cases it is, and you're the only one on your team, then I would definitely recommend going with local hosting. The way I do local hosting for HŌRU is I put everything, the whole repository, inside of a OneDrive folder. So I have my main folder, as you can see in the tree view here, up there, and inside of it I have a folder called repositories. And I use my local Git server tool called Gitea to store the repositories in that folder. This way I get an automatic backup via OneDrive. And I can also use G Suite to replicate that folder inside of G Suite. So just the repositories folder. And by using G Suite and OneDrive, I get 2 backups for the price of their regular subscription. And I think that's great. So not only does this allow me to version control everything I do, but also back them up in 2 places and have access to them from whatever computer I choose. And all I have to do is just go in and log into OneDrive and or G Suite and start downloading those folders. And that about covers source control. I also wanted to take a brief moment to talk about online presence, as I think it's something that's very important. So what I suggest, and the reason I've included a Linux US server in the cost section, is that if you get a Linux server for cheap in the US, then you can put your website there. And also, if you happen to be working in a team, you can just shove the version control system there as well. So that way, for the price of 1 server, you get your website with a self-hosted WordPress, which is free, and you get access to your version control from wherever you are. And I also think it's a great idea to get used to having a website early on, because as your game progresses, you'll start getting attention, and what better way to share your progress with your fans than on your own website? And you can always cross-link Twitter posts and Facebook posts and website blog entries, so I think it's just a benefit, really. So I actually have my US server hosted at DigitalOcean, and I've actually found them to be a great quality host. But if you're in the EU, there's a very, very cheap option that I'd absolutely recommend. It's called Aruba Cloud, and you can get a server for as low as a single euro per month. So that's 12 euros per year. And it's a very decent server at that too, because you get 1 gig of RAM and I think about 20 gigs of hard drive, which for the price of a single euro, I think it's pretty fantastic. And you can always ditch them and go somewhere else. All right, now the last thing I wanted to talk about was just some challenges that you'll probably face as a solo indie game developer, because I think it's important, to see probably what your biggest issues will be. At least these are some of my biggest issues when I decided to go solo. So number 1 is software overload. By far, the biggest problem I have is that I have all these different kinds of software, from modeling to animation, texturing, video, sound, etc. And I have to keep track of all of that, right? I have to know how to make a model in Maya. I have to know how to do programming, C++, Unreal Engine's version of C++ actually. And I have to jump back and forth between all these different applications. And you'll have to jump back and forth between all these different applications if you make it solo, right? So I'd say to get around that, you should pretty much write down whatever you're doing and how you did it. For instance, if you figure out how to rig a character properly in Maya LT, write it down. Use something like OneNote or Evernote or just pen and paper, but create like these mini tutorials for yourself so that a couple of weeks down the line, after you've been busy developing your game's basic mechanics in C++, you can just come back to your notes and see how you did rigging for your next character. The other thing I found to be useful is to group your tasks by tool. So if you have like a couple of buildings to model out, then you should probably group them together and do it sequentially, right? Like building 1, building 2, etc. Because that way you'll probably be working in Maya. So Maya is gonna become your main tool for a couple of days, and you'll remember much more of what you've done previously. Whereas if you'd modeled just a single building, then went straight to Substance, textured it in Substance, and then came back to Maya for the next one. So I suggest grouping your work by tool. Second problem I normally have is discipline. Well, no big surprise there, I guess. And I try and get around that by planning weekly sprints. So in my project management app, Hack and Plan, I'll just go in, and plan out my next sprint. A sprint is something I define as an amount of work that needs to be done in a single week. So every single week, typically on a Sunday, I'll go into Hack and Plan the next week out. All right, and my last little issue is ever since going solo and having left my job, I've picked up some very interesting working hours. So I usually work from 9 p.m. to 5 a.m. and that obviously has an effect on my social life as well as my girlfriend. So if you go solo, I think you really should pay attention to how you plan your days out. All right, so that's basically everything I had to say. If you want, just hit me up in the comment section below and I'll be glad to answer whatever questions you might have. All right, thanks a bunch for listening, guys. Cheers.